Welcome to solverfy.
Okay, so problem number 40 wants us to work out all of the quark combinations of these particles here. So let's start with the first one, A, which is going to be a neutron. So a neutron, it has a baryon number of 1, so there must be 3 quarks. Now, because it has to have a each quark has a baryon number of 1/3. So there must be 3 quarks, and the charge must be neutral. So it has to have 3 quarks because baryon number must equal 1. And the charge is neutral. Charge is 0, so it has to so the charge has to add up to that. And the strangeness, bottomness, and topness, so neutron has bottomness, it has no topness, it has no charm, that all must be 0 as well. So a neutron is going to be equal to, the only 2 quarks that don't have all of those characteristics are the up and down quark. The table number 3, up and down don't have 0 for all of the different quark qualities. So that's going to be some combination of up and down quarks. Now, to conserve charge, we have, so an up quark is a plus 2/3, and a down quark is a minus 1/3. So basically, it would be an up, down, down. So it would be 2/3, minus 1/3, minus 1/3. That would be the only way to create this combination. You have to have 3. You have to have 3 quarks, so it couldn't be an up and an anti-up, or 2. And the baryon number has to be 1, so it can't be, you can't have the anti-quarks because the baryon number B would be minus. Yeah, so there you go. So that's what makes up a neutron. An up, down, down, up quark, down quark combination. So for B, it wants an antineutron. So antineutron is just going to be the antiparticle of this. So the baryon number has to be minus 1. So it has to be the antiparticles of all of these. So it's just going to be anti-up, anti-up, anti-down, anti-down. Now, for part C, the lambda neutral, it has a strangeness of minus 1. Of minus 1. And it has a baryon number of 1. So it must contain 3 quarks in order to add up to a total baryon number of 1. Now, so it also must have no charge because it's neutral, and also it has no bottomness, topness, or charm. So in order to make that combination, you have to use an up, down, and a strange. So because a strange quark has a strangeness of minus 1, has a baryon number of 1/3, and the charges here, you have an up, which is plus 2/3, down minus 2/3, and strange, which is minus 1/3 and minus 1/3. So this is the only way to create those particles, to create the lambda neutral particle. So now for part D, We have the neutral sigma antiparticle. So this has a strangeness. Sorry, that did not write out very well. Strangeness of 1, positive 1. So it must contain a anti-strange quark, because the strange quark has a strangeness of -1. So it must contain anti-strangeness. And it also must contain 3 quarks. And they also have to have 0 charge, 0 bottomness, 0 charm, and 0 topness. So it's basically, again, going to be the antiparticle. It basically ends up being the antiparticle of this. So E0 is equal to an anti-up, an anti-strange, and an anti-down. So if you look, it's got, so an anti-up is -2/3, anti-strange is +1/3, and an anti-down is +1/3, so that becomes a charge of 0. Baryon number becomes -1/3 times 3, which is -1. Strangeness is +1, so everything is conserved, and that is that.